last week we discussed about image collections, which was a bit of introductory part, but today we are going to explore deeply on image collections, and the agenda of today will be discussing about compositing, masking, and mosaic. Then we'll also explore the reducers. Reducers we anticipated to have a chapter by its own, but when we were preparing this session for today, we thought it's good to include it in the session so that we can tackle it at once. Then we'll also be discussing about projection and reprojection, then image visualization, and also later we do the exporting. We will show you how to do the image exportation. There are various ways in which an image collection can be exported, and we will explore those when we reach at that point. Then a bit of a bit of uh, introduction definitions, like this is the it's what we are going to discuss. So we just gave a brief introduction in defining some of the terms that you'll be interacting with in the session. So like in the image compositing, you can see it is a process of combining spatially overlapping images into a single image using the aggregation functions. Now, I want to explain this, and if any one of you has an additional point, you can also chip in and add. Now, for the compositing, it's like you can think about it like when you have different an image collection and you want to get a mean of those image collections, then what you will be doing for you to get that the mean of those image collections is the compositing. Or if you want also to get the median of such an image collection, let's say it's a MODIS or a Landsat image collection, you'll do you'll use aggregation functions. Now these aggregation functions are like the mean, maximum, mean, and the product also. Those are types of aggregation functions which are used to when you are dealing with compositing. Then we are going to also deal with image masking, which is the process of hiding image pixels from a computation. Now you can an image masking, now to explain this, is like if you are trying to an example is like if you are cloud masking, if you are trying to get an image free from clouds. Now that process is now what you are referring as the image masking, and we discussed in the other day that the previous session that you can set the value, the percentage of cloud percentage that you are interested in. That one we talked about that in the previous session. So if we are preparing a notch on that, so it will be ready so that we can have details of that for reference purposes. Then let's go to the next one. So image compositing, mask and also. So the process of what we are going to do today is that we are first going to have to identify our region of interest, then load our image collection. Now today we'll be using the Landsat page. Then we'll also narrow down to our area of interest, which is now region of interest, by filtering bounds. So this is a function which is used when you want to narrow down your project into a certain area of interest. I'm very sure that we know this because we tackled this in the previous sessions. Then we'll be able to select the bands which we will be working with. This time in this our project, we will be using band 3, 4, and 5. There are other bands which we'll explore in the image. Then we have to set our image collection to sender. Now what this means is that dot set sender is a function in Google Earth Engine which is used to set an image visualization at the middle part, at the center part of the interface. Like you see, if you are dealing with, let's say it's a small region like Nairobi or a small region like Nakuru, you will find that if you have not set your your visualization well, it will be displayed, but maybe you will not be able to see it because it is appearing somewhere far away from the map. So the dot set sender function in Google Earth Engine helps to bring in the visualization at the middle part of your Earth Engine interface so that you can be able to see the visualization how it looks like. Then so this is our image collection that you'll be using, and I know I won't assume that all of us are pros, but I will show you how we get this image collection and some of the parameters and properties that we'll be going to use in this before, because this is the code how to get started. But first I wanted to show you how to get this visualization, how to get this image collection in here. So allow me in a moment. I want to show you how to get that image collection before we get moving. Oh, and my attention account is logged out, so I'm trying to log in again. Then okay, I think it's now visible. We are looking for Landsat, this one. So if you want to get this image, this is how you go about it. And I think last time we explored the data catalog. So you get to search from here. This is how we searched our image. So this is how you get to search the image collection that you are interested in. And so Taiwan. It's not coming. It's not coming. It shouldn't be showing me some options here. Now the good is that when you start typing, it starts showing you the prompts so that you can just select. But I don't know why today is not showing me, or because I'm present. It usually shows me the prompts, then I select very fast and get moving.
Search constant.
Sorry? Yes, please. Okay, it seems to be taking some time, but I have it on the other side. But we usually search it from here. But let me share this tab instead to show you where it is. So this is the data set that we are going to be using. So if you are interested to use this data, how you go? So these are the properties of that data. Before you get to start any project, the first thing, even in data science or in any data analytics project, the first thing you identify your problem, identify the project. Like now, for if you are not in a, if you want to address a certain project, first understand the project is very well. Then the second key requirement is to understand the data which you are going to use in that project. Now for us, Landsat H was relevant for us to address all those factors that we wanted to do to check today. So when we are talking of bands 4, 3, these are the bands. So before you get to work with any data, you need to understand it very well. So these are the bands that we are talking about. All these from all this B4, B7 to that point. You can see there is also another one here, which is 30-meter resolutions. Then there are several of them because up to this SAA and VZ, those are all the bands which are associated with that. Then you can also see the pixel size of that band. Like you see, most of them are 30 meters. There are other images which have a very good pixel size and better than this one. But for us, we wanted to use this for our project. Then you also have to see the image properties. Like you can see the cloud cover. If you want to remove the cloud cover in this image, you can see the property itself is here. Then you also see the cloud cover on the land, and then these are the terms of use. Like when you want to use that project, do you have to reference it? Do you have any other thing that is associated with that data? So that's how you get to learn about the data source that you are going to use. Then for you to use it in Google Earth Engine, you can see this is the code which is usually used to load that data. Like you don't have to struggle a lot to think about how am I going to use this, how am I going to use it. You just copy this and put it in the Google Earth Engine, and once you run, it's going to appear in your Earth Engine platform. This is the JavaScript code. If you are pro in Python, you can still load it using the Python code, which is here. But in this other case, you need to have an authentication for your Google Earth Engine using Earth Engine API. For us, we are today using this one, so this is what we'll use to run our project. So that was a brief explanation of about how to go about to understand the data that you are going to use for our project. So let's go back to our presentation then before we resume to the code. And should there be any question, please you can ask. No issue. Okay, so this was the dataset that we were exploring. So that is it. I think I've explained enough, but any clarification or anything you want to add, you can just raise up hand or just open up the mic, excuse yourself, and we'll give you the chance. So
I have a
that was
question.
an yes, please.
Is there like a documentation that tells someone which data to use at a particular point? For instance, I was working with data that looks for that deals with floods, and
Yes,
am I audible?
yes, you are.
Yeah. So I was looking for data that deals with floods, and I was led to finding normalized difference water index. So
Yes.
I'm like, is there documentation that directs you if you want to look for vegetation, these types of data and all that stuff?
Okay. Yes. So for that, what you usually do for me, I won't lie for you that there is some documentation for that. But what for you to identify the right data set to use, what me personally I usually do, I first check regarding now that project that I'm looking forward to working on. I do the research to find which data sets have been used for that project because I most of the researchers have already used the data in related projects or in the same project. So I get different data sets which have been used in that. Then from there I go to the documentation for each data set. Like if it's Landsat, it has a detailed documentation, so I can just go there and read about it very detailed. Then I read on the other one. Oh, because most of the projects have been implemented using different imagery. So I read in different imageries to understand now which one best fits to my problem. But for a specific problem, for me for sure I won't lie to you that I know any specific data for a specific project. What I usually do is I do research to get to understand which datasets are used. Then from there I can now settle on the one which I feel is good upon research. But that is my approach. Maybe also I know the team here has also worked on similar. Maybe they can share their experiences. Anyone to contribute to that question? I think Priska, you can just take it that way. But should I get a good
Yeah,
documentation, I can share with you.
yeah, thank you. But yeah, thank you.
All right. Okay. So we can move to the next part. Okay. So the next part is now the part of loading our datasets. You remember I showed you how we load our data. So this is the code which is used to load our data. And the first thing what we did, we talked about selecting our region of interest. So which is this. At this point we will show you how that one goes. So our Landsat image collection is here. Then we filter date, and our interest was this one here of 2016. Then we talked about filter bounds. These are very, very key functions like filter bounds, filter by date. Then filter bounds, we put it is a function, so we put our region of interest, which is here. So this region of interest, we put it here so that the image will the, the image will only be focusing on that region of our interest, the one which we have chosen. Then these are the bands. I've shown you where you can get the bands. Like if you want that image, you can get all these bands. It depends on the project you're working on. Like if you want to address a different project and different problem, you will choose different bands for this. Then we also define our visualization parameters. So these are the visualization parameters of that image. Then this is what I was talking about, setting our image collection at the center. So we set it, these are the longitude and latitudes, and then we zoom it at level 6. We zoom it at level 6. Then adding layer, the dot add layer function. Now what this means it is that it creates a layer in Art Engine. We will show you how it is, how it does that. Then let's move to the next one, whereby it is the reducers. So these are the reducers which we will be. You can reduce an image collection by the aggregation functions which we mentioned earlier in the session. And this you can see, these are the functions, the aggregation functions that we were talking about. Then we use the dot image collection dot reducer function for you to do this. So we have to have this dot reducer function. Then just an explanation about that is that the computation, the computation of the image is done by getting the median value of all the images in that location. And then this is just another explanation regarding on the image collection, which I believe I've already talked about before. Then we can go to the next one. So this is how you do, this is how you implement it in the code. Like if you want to get the median of that, it is the dataset dot mean function. So this way you are trying to reduce that dataset to find the mean of all those image collections. Like there is something which I wanted to show you. Like you see, like this image here, it's an image collection. It is a stack of images, many images which are collected. Like when that satellite goes around, it gets one image, then another one, then they are stacked. It becomes like a stack of images. So this is what is called, that's what we are referring to as the image collection. Then let's go. So we'll be able to check how we can implement this after in a few minutes. Like you can do the mean, maximum, mean, and sum, and also you can do the product of that. Then let's go to the next. Then there is the mosaicing part, which is now the process of assembling image datasets to produce a spatially continuous image. Now, for mosaicing, I will say that you want to assemble different images. Then you create, like I'm just to give you an example. Like suppose you have gotten an image collection which was created in the year 2019, but for your project you wanted to have an historical information, maybe tracing the years of 2010. Now what you are supposed to do is that you can do the mosaicing, whereby you will merge the datasets of from an image collection which was collected in the years of 2010 with the one which has been collected in 2019. So you can have one continuous, like you can have a long big a long span of period data sets which you can get a lot of information, and in that you use the .mosaic function. You could realize that when we are talking about the JavaScript and Google are thinking just the word by itself, mosaicing, you get a function from that name. You have seen reducers. We are using dot reducer function. It is easy to remember in that way because it is not much complicated, so it becomes easier to get started in before we get into Python part, which is which is a bit advanced. But with the JavaScript part, you can just have the function which is related to the name of whatever you are trying to do to achieve. So we will see this code in working in a few minutes. Then there is the projection part. Then we have the projection. Like there's not what I wanted to let you know is that there's no need to do image projection because image comes by default with its own projections. So but it comes a time when maybe somebody wants to do a different project. You can reproject. What you mean by reprojecting is like you can create you can change the scale of that image. You can change it the from the default scale to a different scale, but there is no need of doing that because by default the, the default scale is the best. But maybe somebody wants to do something different, you can go to the projection, and how you do it is like you use dot projection function. You see how I'm saying things are easy to remember. We are dealing with projection and the function is dot projection. And the next is the projection. Now this is now whereby you have to change the scale using the international standards like the ESP. There's another one. Maybe Irene and Prisca will tell us here. And also Joseph, you know these standards. You can explain to us very nicely. Then so this is the reprojection part, and it is the same, like it is now that changing of the scale, and you can set it to the way you want. Like I tried to change this 43 to 26, and I could change this and then get something different. Then that way that is what we are referring to the projections. Then exporting of our image collection. So after you have done your analysis, you have done everything, and you have identified that the results of which you have gotten are satisfying. You can export your image collection to work on it in other softwares like the QGIS or the ArcGIS or any other geospatial software. So you can export it, and the first way to export it, you can export it into your Google Drive, and this is the process. This is how you do it. You first have to define the data that you are going to export. So and you can give it a name and description. So this is like just naming it. This in description is like you are just naming the data set. You can call it maybe water pollution. This is it. Then you also define your CRS. The projection by default is this is the CRS, but you can change if you have reprojected otherwise you can now change those parameters into this form. Then you can transform, and then you also define your region of interest while exporting your image collection. So these are very key items when you are projecting, when you are exporting your image. You have to define all these parameters before you export it into your drive. But we'll see that in a few minutes. Then there is also another export. Like you can export them to Google Cloud, and also you can export them to Google Earth Engine assets. I think that one I've not included here, but it is in the code, so we can see that practically. So let's get into the Earth Engine so that we can implement these things we have talked about here. And it is advisable that you have your Earth Engine account ready. So let's get started. Now, if there is any concern for the theory part, you can let me know so that we can address it. Okay.
Nicholas, as you're setting up, I have a question.
Hmm.
What is the difference between using the Google Earth Engine, or rather, is there a difference in the data that you collect as compared to GIS or ArcGIS, or is it the same data? Because I heard you saying something to do with exporting it to GIS or ArcGIS. Is there a difference, or is there a reason why you use one tool to do something and use the other one? Could you like explain that kindly?
Should we give this opportunity to somebody like Joseph or Irene to explain, or Priska?
Maybe you can repeat the question, please.
Oh, sorry. So I'm saying, so I think I'm saying, is there a difference between using the Google Earth engine and using like ArcGIS or GIS? Like, do you use the latter when you're trying to solve for a particular problem, or when you're looking for something, or in what scenarios do you use GE, and in what scenarios do you use ArcGIS, and for what reason? Is it clear?
Okay, okay, it's clear right now. So, the reason why we are using the Google Earth Engine, you find that it has already those data sets, the Landsat data set, whereby you can just pre-process them and then you get your product, which will just export as the product, and maybe you do the manipulation in the ArcMap. But for the ArcMap, let's say maybe you want to do classification. First of all, you have to download all the imageries from the USGS Explorer. After you download, you have to do things like you have to mosaic them again, and you have to do the cloud masking. Whereby, if you are doing cloud masking using the ArcMap, maybe if you are doing maybe the cloud masking using ArcMap, you have to maybe to let's say you have to digitize those bands which have clouds, and you subtract them, and then you have to fill using other imageries. While for the GE, you can just use the existing imageries over there and just that the quality assurance bands which will use to do the cloud masking. So you find that it's a lot of work when you are doing that work using the maybe using the ArcGIS. And also in addition, you find that for the GE, when you are doing classification, there are some of the algorithms which ArcMap doesn't have. For example, you find that ArcMap doesn't have random forest algorithm to do classification, whereas it is found in ArcMap in GE, which has high accuracy compared to maximum likelihood, let's say like that. Okay.
John,
Okay,
I,
thank you.
John, I
Yeah,
think good. No,
yes.
Joseph is a GIS, is a GIS specialist, so he knows all the troubles they undergo when they are using the geospatial tools. I also use them, but I'm not much experienced with them. So he has a lot of experience and interaction with them. So I think that's very comprehensive enough. So I want to share with you the Google Earth Engine and to share with you on it on my site so that we can get to start. It shouldn't be visible on your side. If not, please let me know. Okay, I think it's good now. So this was the first part which we were talking about. So what we did, this is what we were talking about, like we search our land search image. Now you see it is now coming up here. I don't know what was the problem in during the other time when I was trying to show you. So you see when you search you can get to see all the types of land search and they are here. So like for us we are using this land search page collection 2 tier 1. So you can see this, and if I click import you will see it will be imported here very fast. So I can decide to use it at this point or uh I have had a message somewhere. Probably it wasn't. Oh, yeah. Probably that was the issue. Yes, that could be the issue. So what I've done is that I have clicked the import. So I wanted to show you. So if you have not interacted with this platform before, it is good that you can try opening it for you to get started. So you can see all the data sets which they are available, and you see you can also click more. So that means that has a lot of data sets, images, which when you click import, it will be loaded at this point like I've done and you have seen it come. So this is the code which I showed you in the previous, like when you want to load the data set. Then we said we will be using band 4, 3, and 2. I showed you where you will get the bands in the image. Yes? Okay, so and these are the visualization parameters which we are defining at this point. Then when we are setting each sender, this is it. So we want to set it at this at the latitude, the longitude and the latitude. Then we zoom it at zoom level 6. Then I want us to run this so that you can see how it is going to come. So you can see like this is now that image collection which has been plotted at this point. We can see You can see at this point it's the image before reduction, which is here. So what we wanted to see is that we want to monitor, are there visible changes after before we have filtered, we have reduced the image, before we have reprojected it to the point up to that point whereby we have already done all these things. So what we did is that we wanted to have each step you can see its results of each step. So this is the image before it has been interfered with before you have done anything. So this is how it looks like. If we were loading a modis, it would be different. It might be you could not, it could be maybe green or something different. But now remember we are dealing with the reflectance, the surface reflectance. Then we want to do, now the next step was to check on the reducers. And these are the layers which we were talking about. It the dot hard layer, the dot map dot hard layer, what is that it is doing, it is adding that layer into this part. You can see it here. So this is just labeling to explain what is happening even before reduction is done. So it is just shows you, it is just showing you what the image is representing, what it's showing us. So image before reduction is done. So we are going to check the the media the reduction aspects, the reducers now. At this point, I'm just going to uncomment everything. Then we get to run up to this point and see what is going to happen. What you will realize is that we will have an additional layer, like a new layer will be added for each aggregation function. Like if we do the product, we have it has to be printed. But in other cases, why we are doing all this is just for the learning purposes. Otherwise, if it was not for such, we couldn't be printing all these all these things printing everything after any function has been carried out, but we wanted to have it detailed and well explained for us to understand. So when we see the layer function, the layers, you can see the sum reduction, the mean reduction. All these layers have been printed at this point. Let's see. So if you want, I want to do something. So what it is showing. So like let's say I want to see the image before it has been reduced. You see how it is looking like. Here this is how it is looking like. So it means that each function has an effect to the image. So when I do the median, you can see that there is a change on how the image collection is looking like. Let's try to see the mean. You can see the mean function has an effect on the image collection. Then also when we choose the maximum reduction, you can see how it is behaving. So but the aggregation function, the reduction technique you are going to implement on image collection depends on the project that you are working on. What is your objective? So then is when you determine which reducer you are going to use. So you cannot just use any reducer at this point, but you need to understand what is the objective of my project so that you can understand, you can determine the best reducer technique to use. So when we select the mean, you can see, and also the sum, you can see how the image is behaving. So each reducer function has an effect on the image collection. So let's go to the mosaicing part. So so I'm going to uncomment this one, then I show you. So mosaicing our data set. Then we'll print. So no, not this. So then we'll be able to print after mosaicing. Then we see how it is going. Our image collection is going to look like. So because I've commented the rest, they will not run. But what is going to run is the above code page. So we'll see an additional layer for mosaiced image. So you can see it is coming up here, but the layers have not completed. You see the mosaic image, here it is. Okay, so I'm just removing the reducer function so that we can examine our mosaic image, how it looks like. So this is how it looks like, the mosaic image collection. So this is this you can now start deriving insights from this image collection. Then let's go to the projection part, which we said is not necessary, but at some situations you can get to you can be forced to do the projections. And when we run, we are supposed to get the projections how it is. Okay, so let's see at the console level, you can see our image projection. It is with the CRS BPSG 4326. We can interfere with it and then change this 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 CRS bit. Then you can see how it is transformed to 1 to 0 up to 1 and 0 up to 5. So those are what we wanted to do is just to print and see how what is the projection of our image of Landsat 8. So that is the information that we wanted to display at this point, but it's not necessary. Just trying to explore our image collection in a detailed manner. So let's go next to the reprojection part, reprojecting. Remember we were discussing about projection and reprojection. Now the reprojection part is when you want to interfere with the scale, you can change it and you will find that the scale changes. So like unit scale, you find that 2000 and 10,000. So if you reproject it at this figure, you can decide it to be something different, and you can be able to see it change. Hmm. So you see what I've done is I changed the initial one and put the 96, and you can see that it has been reprojected to 4396. So that's what we were trying to say. Yeah, you can change the reprojections of that image, and but it is not really necessary. But if need be, you can go on and change your projection depending on the project also. Then next part is now different ways of exporting our image collection. And first we are going to start with exporting it to Drive. The first part is whereby we are going to export it to Drive. I think we did explain about defining all these functions. So our image collection is the median, then description, example to transform, then CRS reprojected, all this. Then we also define our region, which is the region of interest. So the image collection you are going to get is only for that region. Like if you are trying to map flood, or you are trying to map classification or of trees, it will only be for that region which you are interested in. It cannot classify trees or classify vegetation of a different region which you didn't consider in your preparation project. So I want to share to run this. Okay, there is a problem here. The projected is not defined. Okay. Oh yeah. I need to I need to I need to open this so that because it is defined here in between. What's it? Okay. Space bar. Okay, so then we also uncomment this. Then we run this. It shouldn't be able to work. Yeah. So what was bringing an issue is this reprojected which didn't defined and it is here. So when we export, you can see like there's a yellow task here. So if you want to find this image collection, which has undergone all the pre-processing steps, you can run, you can click run, and when you click run, it should be able to go to your drive to a specified folder in your Google Drive. Remember, when you log in your Earth Engine, you use a Google Earth Engine. You use a Gmail or any work email which has a disk space. So you will find this image collection in your drive, in your email disk. Then from there now you can use it in other activities that you are interested in. The next export is when you want to export it into the Google Cloud. And this is how you go about it. Now this happens when you have a Google Cloud account. uh And this is how it goes. So you have to the default definitions still remain the image. You also give it a description. Now we said a description is like a name. If it's Nairobi County vegetation cover classification image, you can define it like that. Then a bucket in Google Cloud, also in NWS or Microsoft, there are buckets. Buckets are like a big a database, no, it's a container, a folder which holds different data sets. So a bucket is within a database. So it's like a folder which stores all your data. So then the file prefix, then you can give it a certain prefix, then CRS and transformation. You can see all these things were happening also when we were trying to export our image collection into Drive. But then there are additionals like the bucket, the file prefix, these two. You have to define them. Then the next one is now when you want to export it into Google Assets. I want to show you. So if you want to export it into Google Assets, it appears at the Assets section tab, like here. I think you can see at where it is appearing. If I export it into Assets, it's going to appear at this region. So uh-huh. So these are some of my assets which I exported. Also I uploaded also here. But for your case, if you want to do anything, you want to export it, a preprocessed image, it is going to appear at this point. Once it's complete, what you usually do is like you refresh this refresh button here, and then you will be able to see it at this point. Then you can start using it, or you can import it into the script by using these arrows. Then if you want to rename it, you can use also these ones. But also you can share with somebody who still what is working on a related project using the same bar. So this is how you do it, and I believe that session has been comprehensive enough, and we are good to go. Good. Should I think we are good now. Yes, Heidi. Okay, thank you. Yes,
I
contribute.
have questions.
Yes, please.
Okay, I'll try to be fast, but allow me to share my screen.
I'm going to just stop sharing so that we can see.
Okay, so can you see my screen?
It's coming.
You, you can see my screen, yeah?
You can see black screen.
Okay.
Yes, yes.
Okay. So I was trying to create this layer. It's
Hmm.
in the water index layer, and then I
Yeah.
had imported this aspect, and then
Hmm.
in this place, in this part,
Where are
I
you
had
clicking?
put um yeah.
Oh, yes, yes. Now I can see where you are.
Is it visible?
Yes.
Okay.
Now you are selecting this filter date part, right?
Yeah. So I had filtered it with this date. So let's say 2020, and then if I run it, I hear my echo. So I had these images. There's supposed to be 12 elements. Let me see. Okay, so
Could you
like my
please
question
zoom
was,
in?
I think the micro
pardon?
is saying something.
Could you zoom
Oh,
in kidogo? Make it
yes, please zoom in. Zoom in. We cannot be able to see clearly.
Okay. Um, I think I've over zoomed. Is that okay?
Yeah, that's okay now. That's okay. Thank you.
Yeah. So I had like 12 layers
Yes.
from December to December 2020. Oh, I know it wasn't working. So 2022. So if I
Okay.
run it, I have this image collections, and then it has two elements. Let me write 2020, 2020 to 2022. Yeah, if you look at this part, you see I have
Yes.
like 13 elements. So my trouble was exporting all these 13 elements at once. So I have this script for exporting the image,
Yes.
but I had to do them one by one. So when I did them one by one, you find these tasks.
Yes.
Um, yeah, when I go to task, I had to export them one by one. But the good thing is I was able to find them on the drive. So like when I exported the RAM. So my question is there a way I can export all these 12 layers, like from this time to this time? Is there a way I can export all of them once? And then that's the one question. And then the second question is on generating charts. I think that one you can address later. But after I had been able to download all this, I was able to have them in my drive, and then I was able to have them on ArcGIS. So I have this layer. and I have all these TIFF files. So I guess the next process I plan to do is to take and adjust them and use them as necessary. So I think that also answers John's question on how to use both of them. Like previously, what I usually did was you go to Kenya Geodata and then you get all those data and then you click them on ArcGIS. But in this part, I just had this line. First, you reduce them with median, and then you clip. So to clip the site, I had uploaded this boundary. So this boundary, I had imported it the site. So if I clip the site, it clips the boundary. The boundary is for Turkana County. So that's how I have the Turkana County layer only. Yeah.
Yes.
So I hope my question is clear on
Yes.
how to just download all those layers at once, and then
Okay.
the other part is how, yeah, the other part maybe we'll look at how to generate charts. I guess that's a different session. And then the last question is there an easier method of modeling floods apart from using all those layers? Thank you.
Uh, okay. Maybe I can come first.
Yeah, sure.
Nick, if that's okay. So basically, your question for the first one is for if whether you can be able to download um, those images at once, right? Now, you can
Yes.
there's two options. There's two options. The first one you can use batch download. I'll be able to share. I can let me look if I have a very sample code for the same or even a link so that you can go through it. So you can download it using batch function. Then the next one, and mostly that one is done in JavaScript. I mean Python API. But then there's also a way you can be able to customize it to be used in the the default API. The next one is you can be able to get a list. Okay? Uh, you can do a list, then you pass in that image collection. I mean that the whole image you've just filtered, and then now you select. You do something like a loop so that it will be able to loop through the whole images one by one. So it selects the first one, it downloads it, then it continues all the way to the last one. Uh, and then the other one, I think those are the two methods you can be able to use to download. So it is possible to do that, but then probably I can be able to share the code with you. Let me see if I have if that question answered this code. Um,
Yeah, yeah. Thank you. I'll explore the batch and the loop.
yes, yes. I'm going. I think I'm going to share some link on that so that you can be able to follow along. It's simple. It's actually simple. And then the other question was, um,
The other was on generating charts for the images. But I suppose that's covered. Is that covered in a topic we are going to do?
okay. We are planning to cover everything all the way to generation of charts. But for that, because it is a concern right now to you. Um, Let me share this code for charts generation. It's actually by Spatial Thoughts. It is a nice one. He tries to explain almost everything in that generation using Google Ad Engine. It's a complete course on that generation in Google Ad Engine.
Okay, I'll really appreciate that. And then is there the last one was, is there an easier method for flood modeling, like predicting floods, apart from using the water index? Ama that's the
Okay.
only way.
The best method for flood estimation, in fact, is not using the multispectral satellites, for example, Landsat. because I know the indices, the water index is actually, that is the, I can see you're using normalized different water index. So that one is, you can be able to derive it from Landsat, uh, Sentinel-2 and all that. The best sensor to use in this particular case is Sentinel-1. And with Sentinel-1, you just do change detection. For example, um, with Sentinel-1, the advantage is that, number one, most of the time when there's an occurrence of floods, and then you need to be rest assured that the clouds are very, very, like, over 50%, right? So the best sensor to use is Sentinel-1, considering it's actually using synthetic aperture radar, which is not affected by clouds or atmospheric haze. So I would actually encourage you maybe to maybe look into Sentinel-1 change detection in terms of flood monitoring. It's a nice one, and the good thing is that there's already available codes to do that, at least to get you started.
Okay, thank you, noted.
Okay.
I think when Michael has talked, we are good. Well, Irene, you want to say something?
No, no, no. I was listening.
Okay. All right. So I think
Yeah,
that's it. The
I hope that.
visualization part. Yes.
Maybe, Nick, maybe one single question for Michael.
Yes.
In
Yes.
terms of like the way you, it seems you have vast knowledge on what exact data or image collection data set can someone use. For example, umesema Sentinel-1 for change detection and flood monitoring. Like, how do you know? Uh, how do you normally know that, let's say, based on the information that you want to generate, how do you know what data set to use, or where can I get them, something of the sort? I don't know if my question is clear.
Okay. Yeah, I get your question, and
Mm.
it's a very important aspect you're bringing. So there is, with the, of course, maybe I'll just go back a little bit. I try to explain why we, why actually Google Earth Engine is very critical to remote sensors and other geospatial scientists. Uh, the reason why Google Earth Engine is so suitable for us, especially remote sensing specialists, GIS experts, and other maybe civil and engineering stuff. Um, it's important because for us we need to measure into the analysis itself, right? Rather than focusing on how to process data and do all that. So, um, having said that, remote sensing, as to be specific, Earth observation, we have got different sensors. Sensors, and for you to select which sensor to use in this particular case, uh, I would um, I would say maybe if it's Landsat, that is the multispectral sensors, or if you want to use hyperspectral. But in this particular case, we don't really use hyperspectral data set in this particular platform, majorly because it's not freely available. Probably you need to purchase it, but you can be able probably to load it here and do some analysis, or for you to be able to use the synthetic aperture radar, which capitalizes on backscattering, which is not literally, uh, it's not affected by the no, like the natural light, for example, the sun, because it is utilizing the active sensors. So, but I believe you have some background in remote sensing, right?
Yeah.
Yes, sure. So, so like for example, if you want to choose, let's say, the always the aspect that the one for flat mapping,
Mm-hmm.
um, Sentinel-1 is the best option because number one, it is it's utilizing microwave portion of the electromagnetic spectra, and therefore it's not really being affected by the atmospheric wind and all out in the atmosphere. So with that, you'll be able even to get clear images throughout. Because if it's clouds, if you're mapping, for example, floods, as usual, there will be rain. So in this particular case, if you want to get maybe to know how was the extent of flooding, you'll get the images maybe just after the rainfall or just after the flooding, just after before, then after, so that you do now the difference and then get the extra. You get now the pixel. So that remaining pixel after you remove the image that was not having floods, that is the pixel containing flooded areas. So that's one aspect. If you want to monitor, say, crop mapping and all that, you know very well that phenological stages is very critical in terms of monitoring growth health and so forth. So with that, you will need
Mm.
a data set that is number one, that is frequently in terms of temporal or revisit time should be frequent so that you can be able to monitor um, the phenological stages at every time. Another thing, maybe if you want to maybe monitor, let's say, land subsidence and it's land subsidence, maybe soil erosion, and so forth. To be specific, land deformations, you'll use synthetic aperture radar because with that you can be able to estimate the interferometric. In,
Mike, Mike,
yes, yes.
do you have a dictionary of those words?
Yeah. So basically, that is the whole thing, Nick. And I think that was a nice question. So the joys of a sensor really matters a lot when it comes to the joys of when it comes to satellite or other observation as a source of data. So it depends on so many factors, ranging from the application itself. So I hope I've answered.
Yeah, you have. That was too advanced from my end. But thank you. I will be
Okay,
consulting.
welcome. Yes, yes.
Okay. So I think
Yeah, I
I
think
think it, I think that is comprehensive enough.
Yeah, it is. We need to maybe find an article to learn more.
Is there a dictionary of those terminologies? You are GIS specialist. Please, you need to compile for us an encyclopedia for GIS.
Now I noticed I did very basic part of it. And I'm like, what is my multispectral? It's like photogrammetry thing and
And the synthetic data. I see Joseph is having his hand on. Maybe you want to crack us with more terminologies. Let's hear you.
No, no, no. So just mine is just an add-on about
Yes.
the flood mapping. I've just shared the link which was done by the United Nations for the flood mapping. So it's their step-by-step recommended practice for flood mapping and damage assessment using Sentinel-1 SAR data in Google Binging. So you can just follow that one and maybe you can just know how to use the Sentinel-1 dataset to do flood mapping. Thank you.
Okay, so
yeah.
I
Thank
think
you, thank
that
you.
is good enough. Thank you, Joseph. I think, and for today's topic, we are coming to the end of image collections.
Hi,
So,
hi, hi. Maybe just before you close, so
yes,
maybe just a question to Mike since he works at our okay, the organization that is Upper Kasarani. So I have a cousin of mine who wanted to take the course on, I think it's GIS or something. How much do you guys charge?
Thank you so much, John, for that question. I think it's very relevant because basically I'm also part of the team who does the training, and we are fortunate enough. Even I do have my student here. I think we can even before I answer John, I can take this opportunity to welcome him on board so that at least he says something, and then now
Yes,
I
yes,
answer.
very important. In
So,
fact, I wanted to welcome.
oh,
I noted very early,
oh,
but
okay, okay,
let's.
great, great.
Yes,
Yeah. So, um, it probably is around. Let me see.
yeah, he's around.
Yes, Liaison. Okay, okay. Yeah, as he's preparing. So John,
Yes,
we does over long. Oh, so John has disappeared. Huh?
oh, yes, Jonas disappeared. Maybe we can have. Oh, there's
Oh
one is.
yes.
You can open it, the mic, please.
Yes.
Hi, have I missed anything? Sorry, sorry. I switched off Kidogo because of internet issues, but I'm back.
Oh,
Oh, okay. I think Nick, you can sort out our visit. Okay, it's okay. It's okay.
Hello?
Welcome.
yes, yes.
Yes, thank you very much for having me here. Michael, you have asked a question, but I didn't clearly know what you are asking about.
Oh, okay. Also, so there was a question that was raised by John, and I realized that you are around. Fortunately enough, Nick had already noticed even before I did that.
Yeah,
So
yeah,
I was
I was around since the beginning. But only the internet was interrupted. I went out and come again in the beginning. But I'm around. I'm listening. I'm
yes.
very interested about the questions of the multispectral and hyperspectral and aperture radar. Of course, these things are more advanced for those who are want only to use the data, because
Yes.
going to the aperture, the SAR information is something for the developers, not for the users, I think.
Okay. 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 Yeah. So basically, the reason why I think we were very happy to invite you because John had something that was almost at least connect with. So I was saying that you were also part of the student that we are trying to learn together there at the RCMRD, and we had that opportunity to do that. So John, so there at RCMRD we do have first of all we offer long-term courses. For example, we offer diploma in photogrammetry and remote sensing. We offer diploma in cartography and GIS. Those are the long courses, and also we offer diploma in information technology and other certificate courses. But aside from that, we also offer short courses, and these short courses we normally they are tailor made. So it depends with the. So sometimes we get students coming in just want to focus on one area, for example, application of GIS in surveying and mapping, application of GIS maybe in resource management, application GIS to be specific in water resource management. So we get students ranging from various fields of application of GIS and remote sensing at large. But basically, the charges normally they depend. They're also negotiable, um, depending with the bulk or the number of courses you want to take. But if you just want to take a single course, we offer them in 2 weeks. So if it's 2 weeks, it's normally starting from 35 to 55,000. That is for GIS, and within the GIS we have different specialization. We have principle of GIS, or fundamental of GIS. We have advanced GIS. Then apart from that, we have now the applications in various areas of GIS. Then we also have you can just come and do remote sensing. So that is for 2 weeks. So that's at 45 to around 55, and that is from 9 to 5 p.m. every day for 10 days. That is for 2 weeks. And then we have another package for 3 weeks. Now, 3 weeks, the charges are normally from 25 to 35, and it's 2 hours every day for all the courses that we do offer. Yeah, thank you.
May I
Well,
add
Yes, yes, yes. Yes, Nick, back to you.
now I think Isala has something to say. Yes, Salah. Oh, okay. So I think also Irene is interested to have an opportunity at RSCMD. Would you give her a hint?
Yeah, do
Oh,
give.
okay.
Yes,
Okay.
I was trying to open the mic. So
Okay.
I want to mention that the Regional Center for Mapping is a non-for-profit organization. So, and it has two legs, the Regional Center Complex, where we do the projects, and the member states come there. It is 220 member states in the East and South Africa. While there is RCTI, the Regional Center Training Institute, where Michael was talking about the courses which is provided there. So it is something that provided for students. And in the next month, we will have also the student hostel where some boarding students will stay within the center itself to continue learning and communicating. So please be our guest there.
Thank you.
Yeah, sure. Actually, I forgot even to mention that. Now, and I think that can be a hint to even you finding your way to RCMD.
Think Michael,
And then also,
I'm also interested.
uh, on the same note,
Yes.
um, it's more of RCMD is more interested of like decisions. Using the GIS to make decisions. If you can be able to come up with a project and come and present at RIC conference,
Hmm.
for instance, that's just one case. You can be able to find yourself there, I think.
You said acquisition.
Like they're interested in like somebody who can be able to identify an issue or like a challenge and be able to solve it using the GIS or remote sensing technologies. So if you can be able to do that and be able to convince the management there that you have something good, especially during these RIC conferences and other activities and training, maybe training capacity that does happen there frequently, and then I think you can be able to find yourself maybe at the right point to be there. So that's how I've seen so many people going there. Though myself, I didn't go there that way.
So, so Michael, we won't ask you the trick you used.
Yeah.
How did you find yourself there?
Yeah.
We
We
wanna
won't,
know.
we won't ask you. For that, we'll get you maybe buying the tent.
Yeah. So, but sometimes, again, currently there are so many ways of trying to, like, for instance, currently there is this mapping competition, though it was closed for registration. I think it's ongoing currently. You see, for instance, I will mention last year the person who won, right?
Mhm.
The person who won the annual mapping competition is
Yes.
actually absorbed as an intern currently as I'm speaking.
Okay,
And
that's okay.
then also there's a prize, and it's paid in euros. So like people are competing, then you win. At the same time, you can even be able to be absorbed if you are doing something that is impressive and yeah. So those are the tricks. Again, there's others. For example, if you know somebody there,
Mhm.
you can also.
Also, that's also another hint.
I know you now.
Yeah,
That's also another hint.
yeah.
That's a
But I
good
can tell
one.
you, yes, but it's very competitive there. Yeah,
Yeah.
it's competitive because actually it's one of the leading geospatial organizations so far in Kenya and in East Africa, East and Central Africa so far.
Yeah,
Yes.
that's true because I do interact with some of the friends from there, but I see the work they're doing. Currently, I'm a
Yeah,
research assistant, but I'm not learning a lot. That's why I'm interested in a place where I can maybe use my expertise and learn more and yeah, learn something that you like. You see, like where I am right now, I'm like actually the expert of GIS there, but you see, my knowledge is still very basic. So I need somewhere where I can be challenged a little bit. Uh,
yeah, sure. That is very true. Maybe that's an advice also. Yeah, and then like something like a mend or something, right? You can it can be a nice one for you.
Sorry, something like
It can be a place where you can be able to hone your skills as far as GIS is concerned.
yeah, very true.
That is true because you'll be able to interact with the people who are practicing GIS on daily basis and remote sensing at an advanced level. Yeah, so you can try those tricks and then see what. Um,
I will resend
um,
it again.
And you can also, and the beauty is that most of the training sessions which happen there are in collaboration with other institutions and organizations. Those ones also get you a better opportunity for you to learn many and new and advanced stuff in relation to Earth observation. Now for me, I'm not specific to remote sensing because I'm not a remote sensor or a GIS specialist, but on Earth observation because I do use most of the tools for the Earth observation. So recently, I started using the remote sensing tools, but I'm not a pro like Michael here, Irene. Also, I know Joseph. You are pro. Yes.
To Irene.
Yeah.
It's always not too late because even if you don't know
Hmm.
now, tomorrow you will be the expert of this knowledge. I give you my experience, my personal. Michael knows it well. 13 years old, I did my master in remote sensing and GIS in Netherlands. And I didn't do it for several years. Now I'm like someone who don't know anything about GIS and remote sensing. So even Nicholas or Michael, if they left this field for 2 years, they will be like they don't know anything because this field is always moving and there is new advancement. So jump now and you will be the best, I'm sure.
sure.
And
Yeah,
and Salah, if I might ask, what's the future of the remote sensing and Earth observation?
Sorry, can you repeat?
Now, if I may ask, how do you see the future of remote sensing and Earth observation with your experience? We know you have a lot of experience in this industry. So, how do you see the future?
I'm seeing it moving to be in the hands of in the mobile phones for everyone. It will be in the primary school, in the secondary school knowledge and learning. Because 15 years ago, to learn ArcGIS, I had to travel from Sudan to South Africa to get a 2 days course with ISRI, Introduction to ArcGIS 8. So now I'm communicating with you. I don't know where are you now. It is online. The open source is there. You can send me the lecture, you can register it. So there is a revolution in this communication that reflected in the GIS and remote sensing. And more people now know about satellite images, about the drone mapping, about the open source ODK and the location and GPS. So it will be in hands-on. But still the people of remote sensing and GIS and JavaScript and programming will be there to develop the applications for people in marketing, in health sector, in different sectors. I hope I answered some of your question about the future.
Yes, you are done very nicely. So I think I think we have done a good work today, and I was saying that we completed the image collection exploration, all the details regarding the image collection, and there was a suggestion by John. I think yes, yeah, John is here. There was a suggestion by John which he mentioned to us earlier that after the after like we have done with any each topic we can do a sample project, then we come and exploit the next session. Like now we are anticipating to have our next session on the next week, Tuesday next week, and today we have completed the introduction part of the of image collections. So the suggestion was like we can do a small project, like you just work on an area of interest, a project of your interest, by applying all those functions that we have learned, all those functions that we have learned, like filtering by date, filtering by fonts, image reduction, also the all those steps that we have gone for the last 3 weeks, last 2 weeks, because yeah, today being the third. So you can do a project that you are interested on, if it is land classification or water mapping or any other thing that you are interested in. But the point is you apply all those functions that we have learned, just to validate your understanding of the topic. Because today we have done the introduction and image collection preprocessing, all of it. Next is the we'll be dealing with the feature collections, which will start later. But I wanted to hear from you if this idea is good, if you can take the challenge and work on something, on area of your interest, a project of your interest, so that next Tuesday we can come and you can just present to us like the way we are doing here. Then you show us this is what I did, this is what I did. Then we can just see, it's a way to validate the understanding of that topic. Just an exercise, a small exercise. Once you are done with that, it is your project. You can put it in your GitHub repository. You can put it in your LinkedIn profile. You can put it anywhere. You can even create an article describing what you are doing, what you are trying to work on. So that way you are building your own portfolio, project portfolio. And that is what it was a good idea. If well, if on your case you take it, we can adopt that if you feel good. Uh, John, you support that? Not John, because John is the one who came up with the idea. Please, that is okay with you? Or Irene?
I think that's fine. That's okay.
Hmm.
Mm. can try pick some time and work on it at least to understand. Uh, if we get stuck, we will get some help here in the next
Yeah,
session.
yeah. What we'll do is we'll upload the last week's session code and this today's session code in our
Yeah.
GitHub, so you can be referring some of the items that you want to implement on the GitHub repository. So we can do that today or tomorrow. In case of, and if the problem persists, if the
Okay.
problem persists, then you can get in touch very fast. Yeah.
All right. Thank you. Yeah,
Mm,
I'm
so,
okay. I'm okay with that.
all right. So, any, I think it's good. So we can work on that. We can try that just to validate this for your benefit. For us, we have, when we are preparing the sessions, we work on everything from scratch. We code everything we do. We prepare the material. So for us, we work on it. So we wanted to put it on a chat on to your site. If you are good, if you want to try it on your site, just work on something of your interest. It doesn't matter the area of your specialization or the area of your interest. You can work on land, water, flood, fire, anything that you want. But the point is just to implement those aspects that we have worked on up to this point. So if that is okay with everyone, next Tuesday we can have a presentation by the members, like, and just show us what you did, how you did it, and I think that could be good. Then
Mm. You came up with the point while majority of members have left, or I don't know. So I don't know if everyone is agree with that or not. Yeah.
Priska, you're good. Yeah, John, I think John is the one who came up with the idea. I have seen Joseph also is in support with this. Joseph is in support with that. Then okay, yeah, we have lesson also is okay. I think that's good. Okay, so if okay, yeah, Chris is there. Yes, I see John has his hand on. Yes, John, you have something
Oh no, 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 I don't have anything. I'm just
in support.
oh, for me, it was just a question to Mike. So Mike, I hope you're going to share with us the knowledge that you have as much as we're not paying anything. That would be really appreciated. We try and exploit you as much as we can. Thank you.
Yeah. Okay.
You
So
think?
sure. Okay. Yeah. Yeah. So we'll have. Yeah. We'll also have the recording of this session, and also the code will be shared in the GitHub, which we'll also share with you. We are also preparing a comprehensive article, like explaining all those things comprehensively in a very nice article. Then we'll share them once they are ready. So thank you so much. So we can.
And Nick, one concern is
Hmm,
you please share the recording, like the way you've been guiding us through all this, not only the code, because sometimes it was only the code that was shared, it was the slides that were shared. We feel like when, of course, during the session, some of us have had questions and you are trying to respond and even showing, and we feel like we have like an extra what do you say, like an extra information that is needed as compared to having only the slides. I hope that's okay.
so we added the recording and also the article, right? Okay. So if I got you well, is that we share also the recording, and Joseph is doing good work.
Yes, yes.
Yeah. Joseph is doing good work in that. And also the article is becomes because it explains everything, like every function, what you're trying to do, everything very clearly. So we will also strive to work hard on that. We have the work is too much, but we try the best, the best, the best. So thank you so much, everyone, and I believe we are good. We have extended, but it was good sharing with you all. We appreciate your time. We appreciate you coming here. So next Tuesday. So we will not prepare the content. We will only be concentrating on preparing our good articles and the recording to share with you. The article will be shared before what? Before that next Tuesday. But the code for the GitHub we will share with you today or tomorrow so that you can start working on your project of interest as fast as possible. So next Tuesday we will be having the presentation. So we can expect a presentation from the members here in present. Just present, show us what you have for everything, and we'll be able to guide more. And I believe that will be a better understanding of the topic of image collections exploration. So thank you so much. You have a good time. We wish you very well. And anything, for sure, anything, please email in that email. Email in that email where you get notifications on. Just reply there and we will guide you very well. So thank you so much. Unless anybody has anything to say, I would say we are good to close the meeting.